Okay.
Jocelyn, I'm like an anfitrion.
What?
Porque puedo ver cada vez que alguien solicite el ingreso.
¿No quieres? ¿No?
Porque se me
Yeah,
tapa,
okay.
se me tapa toda la parte de...
Okay, yeah. I remove you from being a...
Jocelyn, I'm like an anfitrion.
What? Nothing.
Porque puedo...
Okay, yeah, it's ready. I was repeating the presentation in my YouTube.
Yeah. It's like an echo.
Yeah.
Yeah. Mm-hmm.
Can you see me now? I moved.
Yes, Mauricio, you were there.
Yes.
You were looking very dark only. Dark.
Now I changed my in front of the window. Now I am
the position. Yes,
position.
you have to receive the light on the in front of you.
Yeah.
Okay, everything is set. And we'll start at 11 with Noemi's presentation. And
Hi, Jessica. Hi.
yeah.
Yeah.
Buen día.
Buenos días.
Hola, Ramiro. Buenos días.
Buen
Ramiro.
día.
Hola, Ramiro.
Hola, Noemí.
¿Qué tal, Ramiro?
Aquí estamos.
Hola, Jessica y otros.
Hi, Anne.
¿Cómo estás? ¿Cómo estás?
You wake up
Muy temprano aquí.
Sí.
Es demasiado temprano para ponerme mis lentes de contactos.
Sí, nos dijo que eran las 7.
Sí.
You made it, Anne. Good for you.
Yes, you too. Muy bien.
I'm not completely here.
Oh, okay, you're only a figment.
Okay, Noemi, I think we should start.
Okay. Yes. Okay. Well, welcome to all the attendants to our next webinar today in the framework of our IGCP 707 project, Origin, Distribution, and Biochemistry of Arsenic in the Altiplano Puna Plateau of South America. We are conducting, as maybe some of you were in the previous lectures, we're conducting a series of these webinars to let you know and to share experiences and some results of our research in this field of arsenic in South America. Today, we're going to have, well, the leaders of our project are Jessica Murray of CONICET, of University Nacional of Salta, Jocelyn Tapia, the University of Catholic in north of Antofagasta, Chile, Dr. Kirk Nostrom from USA, Geological Survey in the United States, and Mauricio Ormachea and me from the University Mayor de San Andres in La Paz, Bolivia. So today we're going to have a webinar. The title of the webinar is Origin and Geochemistry of Arsenic in Pozuelos Basin. UNESCO Biosphere Reserve in the Argentina Puna, conducted by Dr. Jessica Murray. Dr. Jessica Murray is a researcher at CONICET, Argentina. She works at IBIGO Institute in Salta, Argentina. She has a geology degree from National University of Rio Cuarto and a PhD in geology from National University of Salta. She conducts research on the geochemistry and of arsenic in surfaces of groundwaters and the geochemistry of mining waste and acid rocks drainage. So I leave you with Jessica. Please give your talk. Thank you.
Okay, thank you very much, Noemi, for your introduction. Can you hear me? Okay.
Yes.
Okay, so let's start with my talk. So yes, as Noemi said, I'm going to tell you about the origin and geochemistry of arsenic in Los Pozuelos Basin, UNESCO Biosphere Reserve in Argentinian Puna. The results I'm going to show you are part of my PhD thesis and also my postdoc. And now I'm continuing with my research career, doing research in this place. So, most of you must be familiar with this map, which is the map showing the areas in the world with high arsenic content and where people is affected by drinking arsenic with high concentrations, drinking water with high concentrations of arsenic. One of the regions in the world is well known as the Chaco-Pampean Plain in Argentina. In Argentina, I want to show you this map from 2018. And this map is showing the distribution of the population in green scale and the arsenic concentrations in red and orange. I'm also showing here with a circle the area of the Chaco-Pampean Plain. In this region, we have one of the highest arsenic concentration and also the highest density of population. And the arsenic in this in the groundwaters, it has an origin in volcanic ash and volcanic glass that is coming from the volcanic arc situated in the Andes range. In Argentina, the limit value for arsenic in groundwater, in drinking water, has had a lot of modifications. The last modification was last year, and the new legislations, they set the limit on 10 micrograms per liter. However, for those areas with high natural arsenic content, or those areas where the treatment of water is not possible or difficult to obtain, we can accept values of 50 micrograms per liter. In the case of Los Pozuelos Basin, the study site I'm going to show you, it is located outside of the Chaco-Pampean plain. It is in the Puna region of northwest of Argentina, and is one of the areas where less research has been conducted, and also where we have less density of population. The Los Pozuelos is immersed in a big region known in the world as the Altiplano Puna Plateau. This plateau is the second highest plateau in the world after the Tibet, and it has an elevation about 3,500 meters above the sea level. It's a shared region between Argentina, Chile, Peru, and Bolivia. And in particular, Los Pozuelos is situated in the northern part of the Puna, close to the limit with the Bolivian Altiplano. In this map, we are showing the distribution of the precipitation, which increases from south to north, the distribution of the salt flats in the south area of the Altiplano Puna Plateau is very dry, and the humidity is increasing to the north. And we have a series of lakes, for example, the Titicaca Lake, where we also have a lot of population marked in yellow. Also, we also have here the Lake Popo, and Los Pozuelos, it's the lake that we have in Argentina, in the extreme, where the precipitation starts to be more abundant. This basin is very important from the point of view of the biodiversity in the Altiplano Puna, because the water remains in the lagoon, and it could harbor many species of aquatic birds. This is a picture of the flamingos that usually nest in the lagoon, and also, for example, some birds that are coming from the North Hemisphere, from Canada. We also have the local fauna, the vicuñas and llamas, and people living in this area share their culture with their culture is closer to Bolivia and Chile than to the rest of the Argentinian country. This site, because of its importance, it's a protected area and has been declared a natural monument, a UNESCO Biosphere Reserve, and a Ramsar site. The amount of population in the region is around 353,500 people, and in some cases they drink water from the rivers, but there is a lot of people living in the basin, and they build their houses, and in the backyard they have a well where they take the groundwater for drinking and cooking. The objectives of this research were to determine the geochemistry of waters major ions, and physical chemical parameters, to determine the arsenic concentrations in surface and groundwaters, to provide arsenic speciation data, which is very scarce for the Altiplano Puna, to identify the sources of arsenic, and to identify the effect of the strong dry wet season periods occurring in the area. So now I'm going to show you first the settings of Los Pozuelos Basin, the methodology that we use, the geochemical characterization of the waters, the arsenic in waters, sources of arsenic, and a conceptual model that we started to develop. Regarding the geology, the most important things to take in account is that this is a closed basin, and in the west border, there is a high range, more than 4,000 meters above the sea level, and these are Ordovician shales, marine shales. They have a low grade of metamorphism, and they contain high amount of pyrite. And also in black squares, there are, I marked the presence of gold deposits with rich arsenic. In the south, we have the presence of volcanic rocks, and because of the lagoon had some fluctuations during the Pleistocene, in the center of the basin, the aquifer is composed of lacustrine sediments. And these sediments are surrounded by alluvial deposits, which came from the erosion of the mountains. Regarding the climate, the weather in Los Pozuelos is very extreme. The precipitations occur during the austral summer between December and March. However, for the Puna, it's a lot of precipitation, around 486 millimeters annually. There is a high evaporation and strong winds, especially during dry season, and strong daily thermal fluctuation and UV solar radiation. The methodology that we use between 2011 and 2017, we took 66 water samples. We tried to take samples during dry season and during wet season. However, the accessibility in wet season is not easy because when it rains, the accessibility becomes very complicated and not all the sites can be sampled. So most of our samples belong to the dry season. We were taking river samples, groundwaters, and lagoons. In this map, I'm showing in red the distribution of the river and lagoon samples, and in blue, the distribution of the groundwater samples. We were analyzing cations and ions, and we were also analyzing arsenic species, arsenic 3 and arsenic 5, with hydride generation atomic absorption spectroscopy in the laboratory of the USGS in Boulder, Colorado. We also had data of other elements, trace elements, but in this talk, I'm going to talk specifically about arsenic. The geochemical characterization of surface and groundwater is for the rivers, the pH is alkaline, and the conductivity increases from the upstream areas to the discharge into the lagoon, and the water time is mainly sodium sulfate and sodium bicarbonate and calcium sulfate in those areas where it is close to a mining site. The lagoon, it's also alkaline, and it has a wide range of conductivity that I'm going to show you in another slide. And also a wide range of different composition and soluble elements in the water. And groundwaters have a neutral to alkaline pH, and also the conductivity increases to the center of the basin. And in groundwater, the water type is mainly calcium bicarbonate. Regarding arsenic in groundwater, this is the map that we made for the concentrations of arsenic in the different wells that we sample. In green, we are showing the wells with concentrations lower than 10 micrograms per liter. And these wells are located in the area where the aquifer is mainly composed of alluvial sediments, like if it were an out ring in the basin. And here the mean value for total arsenic is 13.2, and the arsenic 5 has the highest concentration. In yellow, we are showing the wells with concentrations between 10 and 50. And these wells are situated in the directions to the center areas of the basin. And also, here in this area, we observe the presence of 2 wells with the highest arsenic concentrations that we found until now, with more than 50, well 8 and well 6. For these wells, they are situated over the aquifer where the sediments are mainly lacustrine composition. And the average arsenic total is 42.8, and also we also have a higher concentration of arsenic 5 than arsenic 3. In this bar diagram, we wanted to show that for those sites where we took several samples, there are like a variation in the concentrations. And we want to focus in the well W8, which is the one with the highest arsenic concentration. And in this well, what we observed, it was that during the wet season, we were able to take 1 sample in wet season. The water type was calcium bicarbonate, and the arsenic total was 74.3. However, during 2 dry season samples, we found water type of potassium bicarbonate and an increase on the arsenic concentration. And the literature says that it is normal that in closed basins, close to the center of the basin, there is an increase in potassium in the solution, and while sodium can precipitate as efflorescent salts. And we observed that very close to the well 8, we had the presence of thenardite, alite, and eusterite, which are minerals with sulfates with sodium, and correlate very well with the increase of potassium and decrease of sodium in groundwaters. And this is Mr. Nelson Wanko, and he has the highest concentration of arsenic that we could register until now. Then for arsenic in the rivers and in the lagoon, we observe that the lowest concentrations of arsenic are in the headwaters of the rivers, in the upstream areas, except for Candado River, which is draining part of the volcanic rock area, and it has a concentration of arsenic between 10 and 50. However, for example, in Santa Catarina River, we also observe very low arsenic concentrations. But Cincel River, which is the main tributary for the lagoon, it's increasing in arsenic. And the concentrations between 10 and 50 are typical for the area close to the lagoon. During dry season, this river is the main river that provides water to the lagoon, and because there is no precipitations, it has the source of water in the rivers. It's the aquifer. In the lagoon, we observe the highest arsenic concentrations. So here I'm showing the mean value for arsenic in the rivers is 9.5. The arsenic 5, it's again the dominant species. And in the lagoon, the mean value increases to 90.4. And we observe that we can also have arsenic 3 as the main species. In this bar diagram, we are also showing the arsenic concentrations in different years. And in general, the values in each site have a similar value. However, in Los Pozuelos lagoon, we observed that in one period, in 2015, there was a huge increase on the arsenic concentration. So here I'm showing a picture, satellite image of how was the fluctuation of the amount of water in the lagoon during the different years that we were sampling. 2013 and 2015, the lagoon was completely full with water, and then in 2016 and 2017, there were very wet, dry summers, and so the lagoon was completely dry, and only the water was only present close to the area where the Cincel River were discharging. In all the cases, the arsenic concentration was around 50, except for this year in May 2015, where we observed the increment to up to 200 micrograms per liter. So this is a plot showing the concentration of sodium and chlorine in each one of the years, also the conductivity, and also the arsenic concentrations. And we can see that in May 2015, the lagoon shows the highest conductivity, sodium chlorine concentrations, and also arsenic concentrations. And this gray line is showing the arsenic 3. And arsenic 3 was the main species dominant in the lagoon. And when arsenic 3 is dominant, it's more soluble. And so we consider that was making the arsenic to increase in the lagoon. And we also, for this period, we also observed the presence of iron 2 as a dominant species for iron. And so there were a strong redox condition, reductive conditions that provoked the increase on arsenic. And we are still thinking what could be that produced that. And for that, we are starting to study the influence of the biological activity in the lagoon. Regarding the sources of arsenic, we identified three different sources. The first one is the ancient mine, an abandoned mine, which is situated here, Pan de Azúcar mine, which is producing acid mine drainage. The second source are gold deposits in the mineralized shales in the Rinconada Hills. And the third source are the volcanic rocks in the south area of the basin. For the first source, Pan de Azúcar mine, I was studying this site during my PhD. And this mine was closed without any remediation strategy to avoid acid mine drainage generation. And this is in gray. This is the distribution of the tailings in impoundments. And these tailings are very rich in pyrite and other sulfides. We were characterizing the tailings, and this is a picture of the oxidation process in the tailings. The gray area is still the sulfides, which are not oxidized yet, and they are mainly composed of pyrite and marcasite, with a very low neutralizing potential. They don't have calcite. And arsenic is associated to the sulfides, especially arsenopyrite and other sulfides containing arsenic. When these tailings are oxidizing, they develop an oxidation zone where the main minerals are charosite and thermonite. And in this case, arsenic will associate to these secondary minerals. However, when during the rain seasons, a lot of a high volume of acid mine drainage is generated, and we have very low pH from 2 to 4, and the arsenic concentrations vary between 21 and 44 milligrams per liter. And we have measured arsenic speciation, and in all the cases, we observe arsenic 5 like the dominant species. What is occurring in this site is that during the wet season, there is a discharge of acid mine drainage over one of the rivers in the basin, which is a tributary of Sincel River. And this river, we were sampling this river upstream of the acid mine drainage discharge, and we observed that it has a concentration of arsenic. However, after the input of acid mine drainage, this is a sample from this summer, the arsenic concentrations increases, and this is very well observed in the fluvial sediments, where most of the arsenic is absorbed, and we were taking samples up to 6 kilometers away from the mine, and we observed values of up to 108 milligrams per kilogram in the fluvial sediments. The second source, as I was explaining, in the Rinconada Hills, these marine shales, they have a lot of pyrite, dissemination of pyrite, like you can see here in this block in one of the rivers, and also gold deposits associated to quartz veins. In these quartz veins, we have arsenopyrite and rich arsenic pyrite. One of the authors describing these deposits, Rodriguez et al. 2001, he indicates that arsenic is a good element to track high arsenic, gold concentrations. And so we consider this as a source of arsenic because these gold deposits are constantly exposed to weathering and slowly introducing arsenic in the basin. And finally, we have a volcanic source for arsenic, which are ignimbrite rocks that belong to the Coransuli volcanic complex in the south of the basin. These rocks contain a wide range of arsenic from 2.2 milligrams per kilogram up to 126. In general, the rocks have around this the lowest concentration. However, when they show hydrothermal alteration, the concentration of arsenic increases in the rocks. We consider this as a source of arsenic because of one of the rivers, the Candado, shows a high concentration of arsenic, and also these rocks are easily altered by the weathering, and they can easily release the arsenic to the fluvial systems. Well, finally, we started to build a conceptual model to explain the origin of arsenic, its mobility, and how it's going to be finally deposited in the center of the basin. So we have here the three sources: the Pan-de-Azúcar mine, the weathering of the ignimbrites, and the oxidation of sulfides in the gold mines. This arsenic goes to the fluvial systems and also to the groundwaters. Here, close to the mountains, the aquifer is mainly composed of alluvial sediments, and to the center, there is a predominance of lacustrine sediments. And here in this area is where we observe a strong effect or a strong influence of evaporation on the aquifer, because the aquifer is very shallow. And finally, when arsenic goes into the lagoon, it is showing that we have an interaction with the organic activity, the biological activity in the lagoon that can change the arsenic concentrations and speciation and mobility. All of these results that I was showing are were published last year in the Science of the Total Environment. And well, what we consider for the future is that we need to better understand the influence of evaporation in the arsenic concentrations. We need to do a better characterization of the lagoon, and we need to better understand the arsenic mobility from the different sources to the groundwater. Well, finally, to the end of my talk, I want to thank the institutions that giving fundings for the research, and also the institutions that supported our research, our field trips, and our laboratory work, and especially to the people who living in the basin that allowed us to take samples in their houses. And I want to thank the people from the national park, that they were always helping us a lot in all the sampling campaigns. And this is a picture of Blaine McCleskey, that he's helping a lot with the analysis of the arsenic species in Boulder. Thank you very much.
Thank you, Jessica, for this nice and interesting talk. And I don't know if we can start with the questions or
Yes.
yes.
We have 2 questions in the box in the chat, and we don't have questions in the YouTube channel. So one question is from Dina Lopez. Jessica, do you have precipitation information in your area for the sampling period? How the variation in concentration relate to precipitation? That's the first question.
Yes, very interesting question. The information of precipitation that I was showing, it's a series of data that stopped in 1994. And only in 2017, the national park installed, together with another researcher from Buenos Aires, they installed a meteorological station, and only from 2017 we are obtaining the data on precipitation. So unfortunately for the period for the time where I was sampling, there were not data available. We have some estimations, but not the data in situ.
Well, in the meantime, we're running a poll if you can complete. And then Anne is asking, have you analyzed the evaporite minerals, fluorescent crusts for arsenic, or done leach tests on them?
No, we only made X-ray diffraction for those, and we didn't analyze the arsenic, and we didn't make any leaching tests. But that's interesting, Anne.
Yeah, and I was thinking it could be another seasonal source of arsenic to your, that you could add to your conceptual model, which was a very nice model.
Yeah.
Just a thought.
Thanks, Anne.
Then we have a congrats, excellent work and presentation. Thank you for sharing your results of Matthew Sivek. Dina Lopez is asking, in your maps, we see no samples to the north of the basin. Why? And great work.
Yes, good eye. Yes, that's true. Actually, there are not many wells in the north area. And the wells where we were sampling were the schools. And we need to improve the sampling to the north. And yeah, and what was the other question?
Why? That's it.
Why? Yes, because of there is not many wells, but anyway, we need to. There are less wells, but we didn't sample all, so we need to improve it. Also, that what happened is that this is part of my PhD, and I started studying the Pan de Azúcar mine, and we were very focused on the impact of the mine in the downstream in the wells downstream of the mine, which are those wells in the south. That is why we have a lot of sampling in those wells.
We have another question of Camila Poblete. She's asking did you find any relation with arsenic and other trace elements?
Well, that's something we are analyzing now, because we have also the data for lithium, boron. There is not much fluorine in the basin. I started to plot, but I didn't find clear relations, for example, with lithium and or boron. but this is under analysis now.
Another question from Juan Pablo Zamora. He says, excellent presentation, Jessica. I think your work is an important product for water supply planning in the basin. Did you have opportunity to meet water and municipal officials to share them these results?
We share the results with the people where we took the samples. After every sampling campaign, we bring the results, and it's very interesting because some of them, Juan Pablo Zamora, he knows the region. He works in Argentina, in the Quebrada de Humahuaca. Some of these people, they have 2 houses. In general, the one in the low area where they go in winter, and then when in summer, because there is a lot of flood, they go to the upper areas, and they have in general 2 houses. And for example, in the house where they have the highest arsenic concentration, they have another house with low arsenic concentration. So we recommended them to drink the water from the other house. But that's not the best solution, because it would be very nice if they could start using a treatment system for the waters. And yeah, we hope we can help on that.
Mm-hmm. Yeah. Another question from Mauricio, our collaborator. He said, very interesting presentation. Similar geochemical characteristics as my own research in Popó Basin. Question is, how dissolved organic matter present in lacustrine sediments affects arsenic concentrations in the water? Compared with groundwater with probably no dissolved organic matter?
Well, that's a very good question, Mauricio. Unfortunately, I took some organic dissolved organic matter samples, but I was not able to analyze them. So I'm missing that information. Would be nice to have it in the future.
And Ramiro Escalera, he's asking, he says, excellent presentation and work. Do you have some information about the health effects on arsenic contents?
Well, for me, it's the same as for Mauricio, that when I go to the places to take samples, I try to observe if people have the typical signs of palm keratosis, but they don't have this the physical signs of arsenic, the toxicity of arsenic. We were not making any like following or asking much if they have health problems. However, I know that there is not like a register of health problems in the area. That is not done. It has not been done. For example, in San Antonio de los Cobres, in the Puna of Salta, there has been studies conducted in this sense, but in Pozuelos, it has never been done.
We don't have more questions, just that Juan Pablo appreciates your answer, and we have a lot of thanks for the presentation and congratulations.
Sorry, maybe may I have I can do a question, please. Jessica, I'm wondering how many people lives in these places. If there is a health center, or it's very far from the living people, or how is the about the people that lives
Well,
around?
for the Argentinian Puna, Pozuelos has a lot of inhabitants. It's around more than 3,000 people. It's not a lot, but for us it's a lot.
Yeah. Yes.
And they live in small village, very well-known towns for the area, because they produce sheep and llamas, and they sell their products. But there is also a lot of people living in the rural area. And I think this is the most exposed people, because the people living in the village, on the little towns, they take water from the rivers, or the government pay more attention to them, and they try to help with the water quality. But the people living in the rural area, they just drink groundwater, and they don't have any supply of good quality of water, or a water network. And there is a big town 50 kilometers away, which is called Abrapampa, and they are also close to La Quiaca, where there are medical centers. Yes, that's.
Okay, thank you. So maybe it would be interesting to look at this
Yes,
illness in this medical center. Maybe they have some information, and also to apply some questionnaire to know about these people that are exposed to the water. Yes.
Because some wells have a low arsenic concentration, like below 10, and then others have in the limit of 50 micrograms per liter. And I think maybe epidemiologically it's not easy to track, but I think it is very interesting to study.
Yes.
To do what you do, Noemi, here.
Yes, yes, we can coordinate. Okay. Well,
We have some congratulations from Maria Aurora Armienta and Carmen Copier. And Brandon Schneider is asking, is there any indication of how arsenic varies with depth in the aquifer? Were some of the sample wells deeper than others?
Yeah, that's a very good question, Brandon. No, we were always sampling a shallow aquifer, shallow groundwaters. We don't know. We were, yes. And most of these, the deepest wells are around 7 meters depth. And the water table from the surface, it could be 2 or 3 meters. It's very, very shallow. We are also wondering if arsenic 5, the arsenic 5 that we are sampling, maybe is, it could be arsenic 3, but because it's very close to the surface, it's already oxidized. Not all the wells have the pumps, so that we can pump during a long period and then take more. So yes, that's what we have.
Anne is asking, she says, nice presentation, Jessica, worth getting up early for. Is there interest in future gold or other mining in the basin? Is it protected in any way?
Well, there is a, thank you, Anne. Well, On 2018, there is a mine that started producing. It's a mine similar to Pan de Azúcar, but it is for lead and silver. And the gold mines are, in general, they are small size. And they used to be productive during the colony, when the people from Spain discovered the region and they found the gold and they took the gold. But now the most important mines are closed. I know there is always a company doing exploration and trying to see if they can activate one of the mines, but nowadays there is only one mine active in the basin, and there is a very complicated situation for the natural area and the National Park Administration, because there is a lot of pressure. Many people want the mine because they want to have a source of work, but many other people, they don't want because they are afraid of the contamination to the lagoon. So it's a very, I don't know the word in English, but like a complicated topic.
Controversial.
Thank you, Kirk.
Yes, right. Is there enough lithium there to have an interest in lithium mining?
The waters in the lagoon have high concentrations of lithium, but the Pozuelos is not a target for the mining companies because it's a protected area. They cannot. It is there is not allowed to extract any lithium or anything from the lagoon. And so the companies are more to the south of the Puna, where we have a lot of salt flats, and there is many lithium projects there.
Okay,
Yes.
but the lagoon itself is protected.
Yes.
Yes. Okay. Thank you.
But really, the water's too dilute in Los Pozuelos. You need brines to get enough lithium to be economic, and you don't have that here.
But to the south, I guess you do.
Yeah.
Yeah.
We don't have more questions.
Okay. Well, maybe finally we want to thank you very much, Jessica, for the nice and very interesting presentation of your results in this topic. And we want to invite to all the attendants to the next and the next webinar, that it's finally the last one of this year, that will be conducted by Ramiro Escalera on December 11th. And the topic is arsenic removal using photoreactors in a small rural town located in the Bolivian Altiplano. So you are invited to this next and the last webinar of the year. Thank you to all of you, and see you next time.
Thank you for all the interesting questions. Thank you for participating today.
Ciao, ciao.
Ciao.
Nos quedamos.
Chao, muchas gracias.
Nos quedamos unos minutos, Jessica, ¿no?
Okay. We can stay a little bit. Ramiro is on? No, Ramiro is there.
Yes, is here, Ramiro.
Okay, thank you, Jessica. It was a very nice presentation. So